Hello and welcome everyone to my channel Probabilities. So as part of the binary search series, we are doing another question today which is called how to find the peak index in a mountain array. We did a similar question in one of the previous sessions. It is called a valid mountain array. How to determine if a given array is a valid mountain array. Although in that question there was no concept of binary search involved, but deriving from there the mountain array concept. Now, in that mountain array, if we have to find out a peak index, we have to use the binary search algorithm. So anyway, what is a mountain array? What is a peak index? All of that we will cover in this video as well. So stay tuned. And if you're someone who is new to the channel, here's a brief introduction about us. Hi, here's a brief introduction for the ones who are new to the channel. The objective of Code with Ease is to make problem solving in programming simpler. If you are someone who wants to become a great developer and wants to level up their skills, data structures and algorithms is indispensable and you need to form a solid foundation of that. And this is exactly where we come in. Because we post topic-wise video explanations in Java on various coding interview questions that can not only help to crack the coding interview, but also help to improve and refine the problem-solving abilities as a developer. And finally, here is the USP of our channel. We code every solution live, we do not copy paste code snippets. We start off by clearly defining the problem statement, the given inputs, the required output, time and space complexities. We also then discuss the brute force way of solving any question without jumping onto the solution and then gradually move on to the optimal solution. We try to use online whiteboarding wherever applicable to explain the approach and the concepts. So that is all about us. So if you guys also want to be a part of this journey, do support us by subscribing to the channel. So with that, now let's get back to the question. So now continuing with the video, let's go over the problem statement that we have. First of all, what's a mountain array? So it says that a mountain array, its array is a mountain array if these are the following properties. First of all, the length should be greater than equal to 3. And there exists some I in which the elements to the left hand side of the I of that index I, the elements to the left hand side of that particular ith element should be lesser than that of that, and the elements to the right hand side of it should be greater than that. There's a term which is used to describe this. The first point that you're seeing, that all the elements are being lesser than ARR of I, it means the elements are said to be in a strictly increasing order. And in the second point in which the elements to the right hand side of the peak element are lesser than the peak element, means the peak element is the greater one. So we call this sequence as a strictly decreasing order, like right from the peak element, every other element next to it on the right hand side is decreasing in order. So the first is the elements to the left hand side should be in a strictly increasing order. The elements to the right hand side of the peak element should be in a strictly decreasing order. So now that we have a mountain array already which is given to us, we have to find out that index, that is the peak index, such that these conditions are being met. And we have to solve this in O of log n complexity. So very clearly indications are given to us that we have to use binary search because they have said that this is the required time complexity. However, even if it was not mentioned, then also we will have to understand by some other hints. What are the other hints? We can see that some part of the array is already in some kind of a sorted order. Like if we consider the first part, we say that this is strictly increasing order. So increasing order means they're sorted in some ascending order. If we are saying it is sorted in strictly decreasing order, means again it is sorted in the descending order. So some parts of the array is already sorted. Because the some parts of the array is already sorted, hence we can use binary search. So that is another hint which we have to pick up. Straight away in any questions, it is generally not given unless it is a familiar question, but we have to pick up hints from the question, and that is how we understand which algorithm to apply where. So now let's take a look at this examples. This is this array 0, 1, 0 and the output is 1. So which means the index 1 is the peak element. So we can see that the elements to the left hand side is actually in the strictly increasing order, like 0 and then 1. And again from 1 there is a decrease, like from 1 it is going back to down to 0. Let's take this example. So here again the peak element is 10 because it is increasing from 0 to 10, but from after 10 elements are in decreasing order, 10, 5 and 2. So now with that, let's move to the whiteboard to understand the approach for this question. Okay, so now let's try to understand the approach for finding the peak element. So this is the array that I have taken. So in this, from 2 to 7, this is the elements which are in the strictly increasing order, and from 7, 7, 4, 1 are in the strictly decreasing order. Now we have to understand what should be the approach to find the peak element. So as we can see from here, 7 is the peak element. But how do we know that given a array? So as we know, we are anyway going to use binary search like we discussed. So in that what happens is there are two pointers which is defined, the low and the high pointer. One is at the beginning, another is at the end. And then on the basis of that, we determine the middle element, the midpoint. In this case, the midpoint is going to be this element, which is 5. The basic concept for this would be to compare the mid element, that is ARR of mid, and ARR of mid plus 1, means the element currently which is pointed at mid and the next element, the immediate next element. So what we have to compare is if this element is lesser than mid plus 1, so in that case we understand that we are in the left half of the array where the elements are in strictly increasing order. That is why this element is lesser than the next element. So in that case we simply have to move ahead. So the low pointer will be mid plus 1. So now if it is otherwise, that ARR of mid is greater than ARR of mid plus 1, then in that case what we should do? So that clearly means if any element is greater than the next element, means we are at the decreasing part of the array, means we are in this position, in this part of the array. So in that case, two things we have to do. One is we might come across an element which is already the potential peak element. Let's say the mid is over here and 7 is greater than 4, and 7 at the same time is also the peak element. So in that case we will have to store this element, so we can store this current mid whatever we have. But it is also possible that that is not the peak element and we would want to go backwards towards the left to find the peak element. So if at any point we are in this part of the array where the elements are in strictly decreasing order, we have to go this side towards the left side to find the actual peak element. Hence we have to manipulate the high pointer to be mid minus 1. That's it. So this is the approach for solving this. Now let's do a dry run. So as we said that currently the mid is over here and we can see that 5 is less than 7, means this condition is true. So low will be mid plus 1. So low will now move here and the new mid will be calculated. So now in this case the mid is over here. So 4 is greater than 1, means this second condition is now holding true. So in that case we will store this index, that is 5, and high will be mid minus 1. So high will come over. The same check will happen whether 7 is greater than 4, and again now the high will move one step behind. So the moment high goes behind low is when the loop is going to break, and we would have anyway stored the element in this answer variable and we have to return the answer. So yeah, that's all about the approach and the dry run. Now let's write the code for this. So now let's write the code for this. So first of all we'll have this answer variable which we are going to return, and then we'll define the low and the high pointers. We'll have this loop and we'll calculate the mid over here. We'll do this check whether ARR of mid, we'll do this check whether this element is less than the next element. If it is, then simply update the low pointer to be low equal to mid plus 1. If it is else, we'll store this pointer in the answer variable, and then high will be equal to mid minus 1. That's it, and finally we have to return the answer. Run this. So yeah, that's all about this question, how to find the peak index in a mountain array. Stay tuned for more questions on the binary search series that we are right now doing. And thank you so much for watching this video.